Okay, good evening. We're here looking at, for the first time now, a review section that will begin to encompass all the particulars of factoring. And the first thing we need to consider is exactly what is the greatest common factor. Well, that's three words. So to kind of gain a better understanding of this, if you don't have an understanding of this, we're going to pick each word apart one at a time. And we're going to start with a few numbers here. We're going to look at the numbers 12, and we're going to look at the numbers 20. And we're going to look at all the factors that we can get for 12 and 20. So factors are numbers that multiply to it. And usually we try to look at whole numbers. So for example, numbers that multiply to 12 are 1 times 12, 2 times 6, and 3 times 4. Numbers that multiply to 20 are 1 times 20, 2 times 10, and 4 times 5. So what we're going to do now is we're going to take a little time and we're going to go ahead and we're going to list these numbers here in numerical order for each of the factors. So I can write all the factors of 12 as 1, 2, 3, 4, 6, and 12. For 20, I can list all the factors for 20 as being 1, 2, 4, 5, 10, and 20. So now that I have these, I can take a look and I can look at all the factors, and now let's begin to identify what are common factors. And common factors for 12 and 20 include 1, 2, 4, not 5, not 6, not 10, not 12, not 20. So it looks like the only common factors for 12 and 20 include 1, 2, and 4. So these are the common factors that both numbers have. When we want to identify the greatest common factor, we simply look at the common factors and see which one of those is the largest. And in this case, it's going to be 4. So now we don't always have to do this work, and we will learn a shorthand way of doing this in a little bit with numbers. But this is just a basic technique to explain exactly what comprises the greatest common factor. Let's now consider three numbers, because when we have to factor trinomials, we sometimes have to look for a greatest common factor among three numbers. So let's take a look at the numbers 16, 24, and 40. So we're going to take a look at all the factors for 16. These include 1 times 16, 2 times 8, and 4 times 4. For 24, this will be 1 times 24, 2 times 12, and 4 times 6. Oh, one more I forgot is 3 times 8. These are also factors. For 40, we have 1 times 40, 2 times 20, 4 times 10, and 5 times 8. So here are all the factors for these, and again, like I did in the problem above, I'm going to list all these factors in numerical order. 1, 2, 4, 8, and 16. Again, I know I'm going through this fast, but feel free at any time to go ahead and pause the video to collect your notes on this. The factors for 24 in numerical order are 1, 2, 3, 4, 6, 8, 12, and 24. The numerical factors in order for 40 are 1, 2, 4, 5, 8, 10, 20, and 40. So now we have all the factors for 16, 24, and 40 listed in numerical order. So what we're going to go ahead and do now is look at all the common factors for these numbers. So the common factors appear to be 1, 2, not 3, but 4. Let's see, 8 is a common factor. Now, if you take a look here, it looks like, see if we have any common factors between at least 2 of them. Appears not to be the case. So sometimes you may have a factor that's common to 2 of these, but it may not be common to all 3. So if we had a factor that was common to 2 of these, it has to be a factor that's common to all 3 numbers if we're going to talk about common factors. It can't be a factor that's just common to 2 of the 3. It has to be common to all 3. So now that we've identified the common factors of 16, 24, and 40, if we want to identify the greatest common factor, then we can identify that as being the largest number of the common factors, which in this case is 8. Now, this is kind of a long way of doing it, and you have to account for all the factors. Sometimes the numbers you're going to be factor are going to be rather large. Now, there is another technique for doing this, so we're going to take a look at a little bit of a different way of doing this, which is still some work, but is not quite as laborious as this. If you have difficulty trying to do all these calculations in your head and working with multiples and factoring, well, I have a saying. You either have to work with your head or you have to work with your hands. So if you can't do these in your head, you'll have to do these on paper. So we're going to go ahead and take a look, and we're going to go ahead and rewrite 12 and 20 as a product of prime factors. And we're going to see how we can identify the greatest common factor of these two numbers using a different technique. So what I want to be able to do is find the greatest common factor of 12 and 20 using a different technique. So what we're going to do is we're going to take 12 and we're going to take 20 and we're going to make a prime factor tree of these. So 12 I can write as 6 times 2, and then 6 I can write as 2 times 3. So what I'm doing is prime factorization, writing 12 as a product of primes, namely 2 times 2 times 3. 20 I can write as 4 times 5, and then 4 I can write as 2 times 2. So now I can write 20 as 2 times 2 times 5. If I want to find the greatest common factor of these two numbers, what I can do now is identify the common prime factors. So the key idea is the common prime factors. So I look to see what common prime factors they have, and that's going to be 2 times 2, and that will give us 4. And in fact, that doesn't turn out to be the greatest common factor for 12 and 20. So we can obtain the greatest common factor for these two numbers by finding the product of their common prime factors. Let's take a look at the example below for 16, 24, and 40. So we're looking for all the prime factors for 16, 24, and 40. So we're going to do a factor tree for each of these. 16 is going to be 4 times 4. And this will go 2 times 2 times 2 times 2. And that will give us 16. So we're going to write 16 as 2 times 2 times 2 times 2. 24 I can write as 6 times 4. 6 I can write as 2 times 3. 4 I can write as 2 times 2. And the reason I circle these is because 2 and 3, these are prime numbers. I can't divide these anymore any simpler, so that's why I leave them as such. So now I can write 24 as 2 times 2 times 2 times 3. 40, I'll write down here. This is going to be 4 times 10. 4 is 2 times 2. 10 is 2 times 5. So now I can go ahead and write 40 as 2 times 2 times 2 times 5. So now if I want to identify the greatest common prime or greatest common factor for these three numbers, I have to identify all the prime factors that they have in common. So we have 2's that are in common here, 2's that are in common here, 2's that are in common here. So if I take the numbers that are in common, 2 times 2 times 2, that is going to equal 8. And in fact, that gives us the same greatest common factor that we obtained here the longer way. So whether you use this technique, which I don't recommend because this can be pretty long and for some very large numbers it can be really difficult, or whether you use this technique of prime factorization and then multiplying the common prime factors to get the greatest common factor, this is a technique I recommend for finding the greatest common factor. Taking a look at one more type of greatest common factor we need to consider. Now the greatest common factor is also known as the GCF. So you'll hear me refer to that as the GCF in class as well as in future videos when we talk about this for future factoring. One other type of factor we need to be concerned about is factoring variables. So suppose we want to find the GCF for x to the fourth, x to the third, and x to the second. Well, the variables are much simpler, and we don't need to develop any sophisticated rules for this, but I will refer back to this at a later time, this technique anyway. So if we have x to the fourth, the factors of this are simply x times x times x times x. X to the third is x times x times x. And then x to the second is x times x. Well, the long way would be to do it like this, but obviously by looking at this we can see that all three terms, x to the fourth, x to the third, and x to the second, have two x terms in common. So if we were looking for the greatest common factor of these three terms down here, that would be x to the second. A simpler rule is more basic than even this, is to simply select the variable with, or the term that has the lowest exponent. So simply select the variable with the lowest exponent. And when doing that, that will serve as the greatest common factor for all of these. It may not be the biggest one, and it almost never will, but it will be the greatest one that's in common for all of these terms. So that's an important thing to keep in mind, and this is sometimes a point of confusion for students, because what turns out to be the greatest common factor turns out to be the variable with the smallest exponent. But remember, it's not looking for the greatest exponent. We're looking for the greatest number that's in common for all three, which is going to be the smallest one.